Hi chemistry students, this is lesson 8.2 where we're going to begin looking at balancing chemical equations. So the three goals for this lesson are to first of all explain the roles of subscripts and coefficients in chemical equations. Secondly, to recognize that mass is conserved in all chemical reactions, so we cannot violate any fundamental principles, and the law of conservation of mass is one of the fundamental principles. So we have to obey that at all times. And then we're going to practice balancing equations by the simple inspection method. Let's get to it. So to review, one of the fundamental physical laws is the law of conservation of mass. That is that atoms or matter can't be created or destroyed during chemical and physical changes.
Yeah, so in a chemical equation, this means that the total atoms present of each element must be equal for reactions and products.
So, we put that arrow in the middle. It's kind of like the equal sign in this chemical equation. Whatever you have on the left side of the equation has to also be present on the right side. It's very much like algebra. You can't add something to one side of the inequality unless you add the same thing to the other side. So that's the basic concept. So let's look at a chemical reaction here.
So for this first example, it's saying iron combines with sulfur when heated to produce iron 2 sulfide. So
iron
is Fe.
It's going to be Fe, and I'm going to assume that that's solid metal.
Yep, plus sulfur.
Sulfur, also a solid. So the words to produce tells me that's my arrow.
And then iron 2 sulfide, I mean that's iron 2 plus, and sulfide is 2 minus. So that means it's just going to be FeS. Because remember, we always reduce ionic form equations to their empirical formula. So FeS would be the empirical.
So if we look at the equation now, we're showing just Fe, which we can translate as one atom of iron. And then we have a single atom of sulfur. There's no number out front. There's no subscript. And then we have one atom of iron, one atom of sulfur in the product. So this equation is balanced as I wrote it.
Yeah, so we'll have to take looks at more difficult ones in the next example, but some things are self-balanced after doing the equation, so just be open to that idea. All right, next practice. Anyway, sometimes, as we said before, equations are not automatically balanced. So, for example, hydrogen gas and oxygen gas combine to form water. Well, first of all, we have to know hydrogen is a special type of element. It is a diatomic, so it is H2. And then there is oxygen, which is also diatomic. So that's O2, and it's, of course, gas, so to put a little G. And it combines to form water, and water is usually liquid, but it could be gaseous if it was combined with a lot of heat. So right now it's saying we have H2, so we have 2 hydrogens on the left, plus O2, we have 2 oxygens on the left, and on the product side we have H2, so we have 2 hydrogens, but only 1 oxygen. So now we have to put in, not subscripts, but coefficients, there's the word. We have to put in coefficients now. So the H's are already balanced. On the left, we have 2. On the right, we have 2. So now if we look at oxygens, we have 2 here and 1 here. So that means we need to put in a coefficient in front of water, which I would assume to be 2.
So just to make things clear, you cannot, repeat not, and we said this down below, you can't ever alter a chemical formula by changing a subscript, because the equation specifying certain substances, if you change the subscript, you've altered the substance.
Yeah.
We can add as much numbers out front as we need to and change the numbers to whatever. So let's look at what effect adding that 2 out front had, Mr.
So now we have 4 hydrogens here and 2 oxygens. So over here we have 2 oxygens but only 2 hydrogens. So now we have to balance our hydrogens by putting a 2 in front of that. And then the last check, if you really want to, you can go through and add them all up. 4 hydrogens, 4 hydrogens, so 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens, good to go.
Okay, so you don't always have to add a number in front of everything, you just add them where you need them.
So it's a 2, 1, 2 coefficients, so let's try another practice. Alright, so we didn't actually write down these inspection steps yet, but we put them down on this slide, so these are some good steps that you should copy in. And the first step, of course, with the water, we had to write down the skeleton equation. So that would be H2 plus O2 yields H2O.
That's going to have your reactants and products with their correct chemical formulas in the right place, but it's probably most often not going to be balanced.
Yes. So then we look for imbalance like we did before. We had 2 hydrogens on the left, 2 hydrogens on the right, 2 oxygens on the left, only 1 oxygen on the right for the water. So then we find the imbalance, and then we add the coefficients. And then, of course, lastly, then we check each element to see if the equation is balanced. If it all adds up,
then you should be. And the other thing which we didn't get into, but occasionally, if you've added a coefficient to everything, you should probably check to see that they don't have a common factor you can divide out, because the chemical equation is supposed to be reduced to lowest terms.
If you have like 4, 4, and 6, you should reduce it to 2, 2, and 3.
We'll encounter some of those, and we'll coach you through that.
All right, let's do the last practice page. All right, so pictured above is a question that we found, and it's saying sodium combines with chlorine to produce sodium chloride. So
let's write our skeleton equation.
Yep. So the first one is sodium is just Na, plus, we don't have to deal with the phases right now, plus chlorine, which we know is diatomic, yields sodium chloride.
I also need to know that my formula for sodium chloride is NaCl.
It's +1, -1, and then from there we have to balance.
So if we're going to balance this by inspection, we can start by looking at the sodium, and I can see I have 1 sodium on the reactant side, 1 sodium on the product side. So then we move on to chlorine. We have 2 chlorines in the Cl2, but only 1 in the NaCl.
That means we need to put a coefficient.
We can't add a subscript, but we can put a 2 out here. And of course, since there's 2 elements there, we've now made the chlorine right,
but the sodium
we've thrown off the balance on the sodium. So now we're going to come over here. We need to add a 2 in front of the sodium, and then
that looks good. And check it all. Looks good. So let's try another one. We're going to probably cover up ourselves a little bit there. Yeah, so we're going to cover up the last one a little bit.
It's showing through.
There you go. So number 2, it says when solid copper reacts with aqueous silver nitrate. So in that case, they want us to put the type of matter that it is. So solid copper with aqueous silver nitrate to produce aqueous copper to nitrate and silver metal. This is a reaction we have done already in class. So we have to make silver nitrate, which is Ag plus 1, and nitrate is NO3 minus 1, so Ag NO3 yields copper 2 nitrate, so it's going to be Cu plus 2. And then nitrate, of course, is still NO3 minus 1. So it's going to have to be Cu, parenthesis, NO3, and parenthesis 2, plus just silver metal, which is Ag. We've got the AQ on the other one. So
this one's aqueous right here. Sorry about that.
So now we go through and start balancing. We have 1 copper on the left, 1 copper on the right, 1 silver on the left, 1 silver on the right, 1 nitrate on the left, but 2 nitrates.
That's one thing we should probably talk about. It's usually helpful to treat those polyatomic ions as a single particle.
Yeah. So 1 nitrate on the left, 2 on the right, which means we need a coefficient. Sorry, so we need a coefficient. Now we have 2 coppers and 2 nitrates, which means we need to go back over and correct
Wait a minute, I
copper.
Added that at the wrong place.
Yeah,
I need to add that here.
Yes, you do.
Sorry.
I don't think you go back. So just put a 2 in front of the silver nitrate, and we'll cross off the 2 there.
So this is where I wanted to. We did not want it to there.
That should be crossed off. So now we have 2 silvers and 2 nitrates, which means our silver now needs 2 in front of it. So now we have 1 copper, 2 silvers, 2 silvers, 2 nitrates, 2 nitrates. I believe this one's balanced.
So, and just then when we read this, sometimes we'll say it like this: 1 mole of copper reacts with 2 moles of silver nitrate to yield 1 mole of aqueous copper nitrate and 2 moles of silver precipitate.
Perfect. That's the other skill we do need. And then the last question here we have is solid iron 3 oxide and carbon monoxide gas produce iron metal and carbon dioxide gas. So solid iron 3 oxide, so that's Fe2O3.
And you figure that out just by crisscrossing, right?
Yep. Plus carbon monoxide, so that's CO, yields just Fe. And of course carbon dioxide. So now we have to go through and start balancing. So it's 2 irons on the left, which means we need to have 2 irons on the right.
So we'll add the 2 there.
Yep. Now we have 3 oxygens on the left, or 4 oxygens on the left, sorry, because it's O3.
Yeah, you gotta be careful. It shows up into 3 there, plus 1 there.
That's 4, which means we need to add a 2.
2 there?
Yep. This one's going to be a tricky one, Mr. Ferguson. So now I have 2 carbons, 4 oxygens on the right. So now we need to update our number of carbons. Oh, wow, this one's going to be evil.
That's okay, because you run into this. The first 2 were walk in the park. This one's... So now...
we have to put 2 in front of the carbon. So it's 2 COs.
Which just threw our oxygen all a kilter.
Oh, yeah. So now we have a total of 5 oxygens on the left and 4 on the right, which is just evil. So once you reach something that looks like this, this is a good example for what we're going to do in the next lesson, known as the SPAM method. So if you can finish this one off by inspection, be our guest. It's not easy.
It can be done by inspection, and with a lot of playing around. But the SPAM method is really lends itself very nicely to one like this, because if you just can't obviously see where you need to add the coefficient. So we'll use this one as our starting point for our SPAM method lesson.
Have a good night.
Alright, so this is one of those things that you can't get really good at unless you practice. So I've got 2 different practice problems as post-video questions for you. First of all, here is an equation which I'd like you to balance. So we have aqueous HCl reacting with Mg in the solid state to produce this compound and this compound. Add the correct coefficients to balance the equation. Then for the second one, I've given you a sentence only, so you're going to have to write the formulas and generate the entire equation and then balance it. And the equation, or the sentence is, potassium combines with sulfur to form potassium sulfide. Give those both a try, and we can discuss how you made out tomorrow in class.